नमस्कार स्टूडेंट्स, मेरा नाम धन्या और हम लोग ग्रेड 11 केमिस्ट्री का फर्स्ट लेसन कर रहे हैं जिसका नाम है सम बेसिक कॉन्सेप्ट्स ऑफ केमिस्ट्री। इसमें आज हम लोग कॉन्सेंट्रेशन टर्म्स के बारे में पढ़ेंगे। ओके, सो concentration terms, before we study the concentration terms, whenever we talk about solutions, okay, solution is always made up of two components, solute and the solvent. Okay, so always a solution is made up of solute and solvent. These are the components of a solution. There can be many solutes, but solvent is always one. Okay, so let's check out. So students, we just said solution is made up of solute and solvent. There can be many solutes, okay, 2 solutes, 3 solutes, etc., but solvent can only be one. Okay, now how do we know which one is the solute and which one is the solvent? Okay, solute means whichever component is less in amount, we call it as solute. Solvent, whichever component is more in amount, we call it as the solvent. Now let's check out, if a mixture is given to you, how do we determine which is the solute and which one is the solvent? Okay, suppose I have 99 grams of sulfuric acid. H2SO4 is sulfuric acid. Okay, in 54 grams of water. Water is H2, you know, right? Now, looking at the amount, we just studied solute means whichever is less in amount, right? So quickly you will say, okay, solute is water and solvent is sulfuric acid. Okay, looking at the amount. Okay, now students, since you already know how to find out the number of moles, okay, let's determine in terms of moles which one is less in amount and which one is more in amount. Okay, so this, let's hold on for some time. So we will determine the amount of solute and solvent using mole concept now. Moles, you already know what is the formula. Mole is equal to mass over molar mass. Hydrogen is 1, oxygen is 16, sulfur is 32. Okay. Now, sulfuric acid. Let's find out the number of moles of sulfuric acid. Mass in grams is 98 over molar mass of sulfuric acid. Hydrogen is 1, but there are 2 atoms. Sulfur is 32. Oxygen is 16 times 4, 64, which is equal to 98 over 98, which is equal to 1 mole. So sulfuric acid, the amount is 1 mole. Okay. Now let's check out for water. So this is water. This is sulfuric acid. Let's check out the water, the number of mole. Mass is how much? Mass is 54 over molar mass. Water is H2O. So 1 times 2, because there are 2 hydrogen atoms, plus 16, right? So 54 by 18, which is equal to 3 mole. Now tell me which is more in amount, which substance is more in amount, or which substance has more number of moles. It is 3 moles of water. So water is the solvent. Water is the solvent and sulfuric acid is the solute. So whenever in a solution they mention the amount of solute and solvent, don't be in a hurry to determine by just looking at the amount. Please do check the moles. Okay, so the substance which has more number of moles is the solvent. The substance which has less number of moles in that particular mixture is the solute. Okay, so moving on further, what are the concentration terms we will learn today? Okay, let's share the screen. So solute and solvent, these are the ingredients in a solution, and I already told you how to determine which is the solute and which is the solvent, right? Now, the concentration terms, these are the concentration terms we will be learning about: weight by weight percentage, volume by volume percentage, weight by volume percentage, ppm, which is parts per million, mole fraction, molarity, molality, and normality. Today we will be learning until molarity. Okay, until molarity. Molality and normality, we'll do it as another video. Okay. Now, coming to the first one, weight by weight percentages. Okay, these are small terms you need to know, okay, in order to solve different questions. Okay, now students, weight by weight percentage. Okay, now in this, if I say, just share this by weight percentage. Sometimes they write it as mass by mass percentage also. Okay, so weight by weight percentage. So if I say I have a solution of NaCl, just look, NaCl in water is 5% weight by weight. So if this information is given to you, a solution of NaCl in water, salt in water, is 5% weight by weight. Weight of the solute, weight of the solution. Okay, so that means I have 5 grams of NaCl, 100 grams of, solution. So weight by weight percentage means the mass of the solute and the mass of the solution. Okay, we talk how much grams of solute is there in 100 grams of the solution. Now, so the formula will be weight by weight percentage is mass of solute over mass of solution. Because it is percentage, we express in 100. Okay, so this is how you do. For example, if I say, suppose an aqueous solution, sugar solution is 10% weight by weight. What does it mean? That means I have 10 grams of sugar in 100 grams of solution. Right? This is how you do. Let's solve some questions based on this. Okay. So this is the question. So this is the formula, weight by weight, how much mass of the solute by mass of the solution times 100. Okay. So this is the question. So please take a screenshot of the question. So 20 grams of calcium oxide is dissolved in 100 grams of water. So let's check out. So the question is, 20 grams of calcium oxide is dissolved in 100 grams of water. Find the weight by weight percentages. So weight by weight percentage. Weight by weight percentage is mass of solute by mass of solution times 100. How much is the weight of the solute, calcium oxide? So calcium oxide, the mass of calcium oxide is how much? Mass of calcium oxide is 20 grams, and water, mass of water is 100 grams. Okay. Now, what is the mass of the solute, which is calcium oxide? It is 20 grams, so weight by weight percentage is mass of solute, that is calcium oxide, is 20 over. We only have mass of water. How do we know the mass of the solution? So is it we add the mass of the solute and the solvent, which is 100 plus 20. That makes solution because it's not solvent, it's solution, times 100. So 20 by 120 times 100, which is equal to 16.66%. Okay, so this was the first question. Now, coming to the next question. So I'm keeping the formula as it is. Okay, this is the first question. Now, coming to the next one, next question, we have 10 grams of NaOH is present in 100 ml of solution. Okay, so I'll just write down the information what is given. Okay, so mass of NaOH is 10 grams, is present in volume of solution is, this time they didn't give the mass of the solvent or solution, they gave the volume of the solution, which is equal to 100 ml, and you need to find weight by weight percentage. That's what you need to find out. What information they have given is density is equal to 1.2 grams per milliliter. Okay. Now, you have the density, you have the volume. Can you find out the mass of the solution? Mass of solution equal to, if we know the volume, if we know the density, can we find out the mass? Volume times density. This formula you must be knowing, right? Now, volume is 100 ml. Density is 1.2 grams per ml. So, what do you get? Do you get 120 grams? This is the mass of the solution. Now, can we find out weight by weight percentage? Do we have the mass of the solute in our hand? 10 grams, right? Do we have the mass of the solution? 120. times 100. So it comes to 8.33%. So this is how you find out the mass by mass percentage or weight by weight percentage when density is given, if they have not provided you with the mass of the solution. Okay. Now students, coming to the next concentration term, which is, so if you understand this, the next one will be more easy for you. Okay. Volume by volume percentage. So volume by volume percentage means volume of the solute by volume of the solution times 100. Okay, so let's check out. Volume by volume. I'm writing it as V. Okay, volume by volume percentage. So if I say an aqueous solution is an aqueous solution, you know the meaning of aqueous solution, right? Solution in water. An aqueous solution is of HCl is 10% volume by volume percentage. I'm writing it as V by V percentage. Okay. So an aqueous solution of HCl is 10% V by V percentage. That means 10 milliliter of HCl in 100 ml of solution. So that means V by V percentage, as I showed you in the PowerPoint, is the volume of the solute by volume of the solution. Volume of solute by volume of solution. In all these, the denominator is solution. Okay, they are talking about solution. So it's easy to remember. Until now, yeah? Okay. So this is how you do it. Okay, let's do the first question. If I say, 20 grams of calcium oxide is dissolved in 100 grams of water. Okay, find the, sorry. Okay, students. So this is how you do if volume by volume percentage is given, that means it's the volume of the solute dissolved in 100 ml of the solution. Okay. Now let's move on to the third concentration term. Weight by volume percentage. Okay, so since you know weight by weight percentage, volume by volume percentage, I think you will be able to guess this one. And this is very important. A lot of question comes from this part. Okay, now this is the formula. I'll just show it in the whiteboard too. So please take the screenshot of the question so that we will do it directly. So I have weight by volume percentage. Okay, now students, suppose I have a sucrose solution is 6% weight by volume Okay, so that means I have how much? That means how much of sucrose solution is 6% weight by 6 gram of sucrose in by volume means you have the mass of the solute in volume of the solution. So that means weight by volume means this one is the mass of the solute, this one is the volume of the solution, which comes to mass of solute over volume of solution times 100. So this is the formula. So weight by volume. The first one refers to solute, the mass of the solute. The second one refers to volume of the solution. So this formula you have to keep in mind. Okay, this is the formula. So let's do a question. There are two questions. Hope you have taken the screenshot of the question. So I'll just write down the formula over here, okay, on top. I have weight by volume percentage is equal to how much? Mass of solute by volume of solution times 100 because it's in percentage. Okay, now the first question is a sugar solution is 10 grams weight by volume. So sugar solution is 10% weight by volume. I'm just writing the short form, okay. Find weight by weight percentage. So what is the question that you have? Weight by weight percentage. This is the question. What is the information given to you? Density rho is given of the solution is density rho of the solution. Density is represented by rho, okay, is given by 1.25 grams per milliliter. Okay. So the formula is written. We have the formula of weight by volume, right? So if I say sugar solution is 10% weight by volume, so that means I have 10 grams of sugar in 100 ml of solution. Now, if I have, because I have been given weight by volume, right? So 10 gram of sugar in 100 ml of solution. Now, I don't know, you have to find out weight by weight. I have the weight of solute in my hand, but I don't have the weight of the solution. So what I must do, I just have the volume of solution. Volume of solution is how much? Volume of solution is 100 ml. Okay. And what is the density of the solution? They have given in the question, right? 1.25 grams per milliliter. So from here, just a while ago we did mass is equal to, how do you find the volume, the mass of the solution? How do you find the mass of the solution? So volume times density, which is equal to how much? 100 ml times 1.25. So how much do you get? 125 grams of the solution. So from here, can we put it in the formula? We have weight by weight percentage. I'll use another color. Weight by weight percentage equals, what is the weight? Mass of the solute. Mass of the solute is how much? 10 grams, right? Over. What is the mass of the solution? 125 times 100. So when you solve this, you will get the answer. Okay, so I hope the density, if the density is given, you can find out the mass. Even if the mass is given, you can find out the volume if the density is given. Okay, so this is how you do. So these type of questions are very common about weight by volume percentages. Okay, let's do another question that was there in the PowerPoint. So I'll keep the formula as it is. Similar questions, but because if density is given, you must know how to find out the mass and the volume. Second question is a solution of HCl. This was shown in the PowerPoint and just writing down the information that's given. A solution of HCl is 10% weight by weight. 10% weight by weight. Weight by weight, you know, mass of the solute by mass of the solution times 100, right? So that means I have, what you have to find out, find the mass of the HCl. So mass of the solute, mass of HCl, they have asked to find out, present in 100 ml of solution. Mass of the HCl in 100 ml of the solution. So solution, mass of solution. Mass of solution is 100 ml. Sorry. Volume of solution is 100 ml. And rho of solution, rho means density of solution is given to you, 1.5 grams per ml. Now, weight by weight percentage is given to you. So, weight by W percentage, I'm writing it like this, W by weight, W percentage is mass of solute by mass of solution times 100. From here, is weight by weight percentage given to you? How much it is? Isn't it 10%? Right? Now, mass of the solute, you have to find out. Mass of solute, you have to find out. Now, mass of the solution you don't know. So, are you provided with the density? So, I'm writing it here. Mass of solution equal to volume of solution times rho of solution. How much is the volume of solution that's given to you? 100 ml times, what is rho? 1.5, which is equal to 150 grams. Now, this is so 150 gram is the mass of the solution. So, weight by weight percentage is given in the question, 10, right? Mass of the solute you need to find out. But do you know the mass of the solution now? 150 times 100. So how do you find mass of the solute? So 15 grams. This is how you find out the mass of the solute. If you are given the weight by weight percentage and volume of the solution, you can easily find out the mass of the solute, right? So these were some of the questions, and these type of questions are very important. I hope you understood. So weight by weight percentage, volume by volume, weight by volume. So weight by volume means weight of the solute by volume of the solution times 100. Moving on further to so these are the two questions we finished. Weight by volume. Coming to the mole fraction. Okay, students, coming to the third concentration term, which is called as. So I have mole fraction. Suppose I'm taking a mixture. Maybe it has two components, A and B. It can be three components, four components, etc. As I told you, solute can be many. There can be only one solvent. But suppose this mixture is made up of A and B. And suppose I have 1 mole of A and maybe 5 moles of B. Okay. So 1 mole of A and 5 moles of B, suppose. Okay. Now, mole fraction is the term to find out what fraction of A is there in the solution or what fraction of B is there in the solution. So if I say fraction of A, that means 1 is the number of moles of A by the total number of moles. What is the total number of moles in the whole solution? 1 plus 5. That means 1 by 6. So 1 by 6 fraction of A is there in that particular solution. Similarly, if I say fraction of B, how much fraction of B is there in the solution? So that means 5 is the number of moles of B over what is the total number of moles present in the solution? 1 plus 5, 5 over 6. So that means this mole fraction is a concentration term to determine what fraction of the different components are there in the whole solution. Okay. Now, mole fraction is given by, is denoted by, it's a X sort of thing. It's called as chi. Okay. In some books, they refer to as eta also. So chi, it's like an X symbol, a capital X type of a symbol, is given by number of moles of A by total number of moles. This is mole fraction of A. I'm referring to this example. Okay. So if I write chi of A, number of moles of A by what is the total number of moles? Number of moles is Na plus Nb. Right? So I write it here, Na plus Nb. What is Na? Moles of A. What is Nb? Moles of B. Okay, so this is how you find out the mole fraction. That means how much fraction of substance or components are there in the solution, or what fraction of component is there in that solution. Similarly, can I find out the mole fraction of B? So I'm just rubbing this part. Chi of B. That means mole fraction of B is given by what? Number of moles of B by total number of moles. If I have three components, if there is a third component, number of moles of C over total number of moles. Okay, so in our example, we just took two components. So I'm just writing this. So this is the formula, students. Mole fraction is given by ratio of number of moles of one component over total number of moles present in the solution. Okay. Now let's do one question. Okay. So I'll just write the formula at the side and then do the formula, do the question. Okay. So mole fraction Chi is given by number of moles of A by number of moles of A plus number of moles of B. That means total number of moles. That's it. Okay. Okay. Now the first question is 40 grams of NaOH, 40 grams of NaOH and 54 grams of water. This is our mixture. Okay, 54 grams of water. Now, you need to find the Chi of NaOH. Okay, so Na is 23, oxygen is 16, hydrogen is 1. Okay, so our mixture is made up of sodium hydroxide and water. Okay, so Chi of NaOH, how do we find out? The formula is given, number of moles of NaOH by number of moles of NaOH plus number of moles of water. Is this our formula? So we have to find the number of moles of all the components first. That means NaOH and water. So number of moles of NaOH is given by, what's the formula for number of moles? It's given by mass in grams over molar mass. I have provided the mass numbers. Okay, so number of moles of NaOH. What is the mass of NaOH? 40 grams over. How do we find the molar mass of NaOH? So students, we have to find the mole fraction of NaOH. So for that, we need the number of moles of different components, and then we divide number of moles of NaOH over total number of moles, right? So number of moles of NaOH, mass is 40 grams over. What is the molecular mass of NaOH? So this is 23 plus 16 plus 1. That is equal to 40, which is equal to 1 mole. Okay. So our work didn't finish here. We need to find the number of moles of water too, because we need it for the total number of moles, right? So mass of water is given 54 over. Hydrogen is 1 times 2 plus 16. So 54 times 18, which is equal to 3, right? Which is equal to 3. So what do we do? How do we find the number of moles of NaOH? Now, can we use this formula? So number of moles of NaOH, how much it is? Is it 1 over? What is the total number of moles? 1 plus 3. So 1 by 4. This is our answer, right? Which is equal to 0.25, right? Now, students, can we find out the number of moles of water? I mean, the mole fraction of water also? For water, what is the formula? Finding the mole fraction of water. Number of moles of water over total number of moles. So how many moles of water is there? 3 over. What is the total number of moles? So 3 by 4, 0.75. Now, why I asked you to find out this one is, just rubbing off this one. If you see, the moles of NaOH is 0.25, sorry, mole fraction. Mole fraction of NaOH is 0.25, mole fraction of water is 0.75. When you add up these two, does it give you, when you add these two, does it give you 1? It should give you 1, otherwise you have a calculation mistake. After all, mole fraction is nothing but fraction of the number of moles present, right? Or how much, what fraction of component A and component B is present. That's mole fraction. So whenever you find out the mole fraction, sum of all the components of mole fraction should come as 1. Okay. So students, whenever you're finding out the mole fraction of different components, the sum of mole fraction of different components should be equal to 1. So as in this case, you can see mole fraction of NaOH and the mole fraction, sum of mole fraction of NaOH and water is equal to 1. Okay, so let's do one more question using weight by weight. Okay, so I hope it is clear. So mole fraction is nothing but fraction of the component present in the solution. So I'm keeping the mole fraction formula as it is. Okay, second question is, students, this is my next question. An aqueous solution of ethyl alcohol C2H5OH is 46% weight by weight. You have to calculate the mole fraction chi of C2H5OH. Okay, so I know my solute, I know my solvent, that is water. Okay, but here they have not given you the mass directly. Instead, they have shown in the form of weight by weight percentage. So weight by weight percentage, 46% weight by weight percentage means I have 46 gram of ethyl alcohol in 100 grams of solution, right? So from here, I know the mass of ethyl alcohol, which is equal to 46. Now, from here, what is the first thing I should do? Can I find the moles of ethyl alcohol? Sorry. I can find the moles of ethyl alcohol. So what is the formula for moles? By now, you would be knowing the formula. Mass over molar mass. So mass is 46 over. I have provided the mass numbers or the masses here. So 2 times 12 plus, there are 6 hydrogens, times 1 plus 16, which is equal to 46 by 46, which is equal to 1. Okay. Now students, we have a small problem here. We know only the mass of solution. Okay. So mass of solution, or rather I will put it in the form of a table so it's easy to remember. I have ethyl alcohol, I have water, I have solution. Okay, ethyl alcohol is 46. Okay, solution is 100. Can we find out the mass of water? So it's nothing but 100 minus 46, which is equal to 54. So our problem is solved over here because we need the mass of the solvent for finding out the number of moles, right? So moles of water, 54 over hydrogen is 1 times 2 plus 16, which is equal to 18, and it is equal to 3, right? So I'm just rubbing this part. I hope it is clear, students. So chai of C2H5OH, formula is written on top. Number of moles of ethyl alcohol is 1 by number of moles of water plus ethyl alcohol, the total number of moles. It comes to 1 by 4, right? Which is equal to 0.25. Now, without finding out the mole fraction of, without solving it, can you directly do the mole fraction of water now? I already told you the sum of mole fraction of different components is equal to 1, comes to 1, right? So mole fraction of C2H5OH plus mole fraction of water is equal to 1. So if you know 0.25, can you easily find out water? 1 minus 0.25, which is equal to 0.75. So this is our mole fraction. Okay, so you just have to know the formula, and you need to know the sum of mole fractions of different components in a solution is equal to 1. After all, it's a fraction. If it doesn't come to 1, then you have to check your calculation, right? Okay. So this was our mole fraction. Okay. We have done this. We did some questions also based on this. Okay. Now coming to the next concentration term, which is equal to parts per million. Okay, students. Coming to the next concentration terms, which is called as parts per million. Okay. Now, this is used for very small concentration terms, like, for example, if you need to measure the hardness of water, in industries it is used, okay? How much of impurities are there, measuring the hardness of water, we use parts per million, okay? Million means 10 raised to 6, okay? So I'll just share the screen. So students, our next concentration term, as you saw in the PowerPoint, parts per million, it is represented as ppm. It's a very small concentration term, okay, for measuring very small concentrations, okay, and million means 10 raised to 6, okay. Now, if I say I have 5 ppm of parts per million sugar solution, that means I have 5 grams of sugar in 10 raised to 6 gram of solution. So see, such a minute amount, 5 gram in 10 raised to 6 gram of the solution. Okay, so it is used to measure very small concentration terms. Okay, so I have parts per million. The formula is mass of the solute by mass of solution. See, in all these terms, solution, the denominator is always about, they're talking about the solution, okay, whether it's volume or mass, okay. So 10 times 10 raised to 6. This is our formula for ppm. So it just refers to how much grams of the solute is there in 10 raised to 6 gram of the solution. That is the million. How much parts is there in million parts by mass of solution. Okay. Now, we will just do a question based on this. Okay. Just write down the formula over here. ppm, mass of solute, mass of solution times 10 raised to 6. Okay, so let's do a question based on this. Chlorine, Cl2 stands for chlorine, okay. Chlorine is dissolved in water okay, as 16 into 10 raised to minus 4 grams chlorine in 100 grams of water. So, chlorine I have dissolved in water, and they have given you the mass of chlorine, how much it is dissolving in 100 grams of water. Find parts per million. Now, parts per million is given by, the formula is given, mass of the solute over mass of the solution times 100. Okay. Over here, okay, students, I have written down the formula over here. Let's do a question based on this. Chlorine is dissolved in water and 1.6 grams, 1.6 times 10 raised to minus 4 grams of chlorine is dissolved in 100 grams of solution. Okay, you have to find the ppm, right? So it's a direct application of the formula, okay? 1.6 times 10 raised to minus 4 over, what is the mass of the solution given is 100 times 10 raised to 6, right? So when you solve it, it will give you the answer, and it comes to 1.6 ppm, parts per million, okay? So here they might also ask you, like giving you the parts per million, they might ask you the mass of the solute, okay, giving all other information. So this is just a concentration unit for measuring small amount of the substances, okay. Okay, students, now we come to our next concentration unit, which is called as molarity, okay. So our next concentration unit is molarity. Okay, so as you can see, molarity of a solution tells you about how many moles of the solute is there in 1 liter of the solution. Here also they are talking about solution. So how many moles of solute is there in 1 liter of the solution, right? So let's check out. Molarity, okay. So molarity is always represented by capital M, okay. This is the unit they give, okay. So it tells you about the number of moles of solute in 1 liter of solution. 1 liter of solution. Molarity, it is represented by capital M, okay, and it tells you about the number of moles of solute in 1 liter of solution. If I say 2m, capital M is how you denote molarity, 2m of NaOH. That means I have 2 moles of NaOH in 1 liter of solution. 1 liter of solution. So that comes to molarity is given by moles of solute over volume of solution. This is the formula for molarity. Okay, so let's do a question based on this molarity, some direct question first. So I'll just write down the formula over here. Moles of solute by volume of solution in liters. Right. So I have first question as 40 gram of NaOH in 200 ml of solution. Okay, I need to find molarity. I've written down the formula over here. So for that, I need to find the moles of NaOH. Sodium is 23, oxygen is 16, hydrogen is 1. So what is the formula for moles? Mass over molar mass. So mass is how much? 40 gram over 23 plus 16 plus 1. 40 over 40, which is equal to 1. Now, if I say molarity, moles of NaOH over volume in liters. So moles of NaOH is 1. Volume of the solution is 200 ml, but we have to write in liters. So I'm dividing by 1000. Okay. In order to convert it into liters. Right. So I have 1000 by 200, which is equal to 5 capital M. So this is how you do. So because 1 liter equal to 1000 milliliters. So this is how I convert liters into milliliters. Now one more question. You need to find the molarity of maybe 9.8 grams of sulfuric acid. Hydrogen is 1, sulfur is 16, oxygen is 32. Okay, in 500 ml of solution. So these are just a basic direct question just to make you acquainted with the formula. Okay, so molarity, the formula is given. First, you need to find the number of moles of. So I'm doing it directly. Molarity equal to number of moles of sulfuric acid. So mass is given to you. Moles, how do you find moles? Mass over molar mass. Mass is 9.8 over. Sulfuric acid is, the molar mass of sulfuric acid is 2 times 1 plus 32 plus 16 times 4 is 64, which is coming to 98 molar mass over 500, but it is in milliliters. I need to make it into liters. So when you solve this, it comes to 0.2 capital M. Okay. So this is how you find out the molarity when the mass is given to you. Okay. Now, students, there can be another question like this, where you are asked to find the mass Na2CO3, sodium carbonate, in 250 ml 3 molar solution. Okay. Now here, molarity M is equal to mass of moles of sodium carbonate over volume divided by 1000, because I need to make it into liters. So over here is molarity given to you. Molarity is equal to 3, right? So from here, can I find the moles? 3 times 250 by 1000. 3 by 4, right? I have the moles. So moles equal to what? Mass over molar mass is moles, right? So 3 by 4. So do I have the molar mass? Can I find out the molar mass? Sodium is 23, carbon is 12, oxygen is 16. So I have 23 times 2 is 46 plus 12 plus 48. So mass equal to 3 by 4 times 60 plus 46, it comes to 106. This one comes to 106. 106. So, which is equal to 79.5 grams. Okay. So this is how you find out the mass when all other informations are given. Right. Now, there's another question. Find the molarity of 10 percentage weight by weight aqueous solution of H2SO4. Okay, and the density of the solution is given 1.1, okay, grams per milliliters. Now, if I have 10 percentage weight by weight, that means what? I have 10 grams of sulfuric acid in 100 grams of solution, right? Over here, can I find the volume of solution? Volume is given by what? Mass over density, which is rho. Do I have the mass of the solution in my hand? Yes. And the density is 1 by 1 grams per ml, and this is grams. Sorry. This is grams, right? This is grams. So, from here, can I find the moles of sulfuric acid? 10 over, mole is what? Mass over molar mass. So 2 times 1 plus 32 plus 64, which comes to 10 over 98. Okay, so I'm just substituting it directly. Molarity, the formula is given over here. Moles of the solute, which is equal to 10 by 98 over 100 by 1.1. And this, you can see it is in milliliters. So I have to divide by 1000, right? When you solve this, you get the answer. Whatever you get is molarity. So did you understand why I divide by 1000? Because you can see it is in milliliters, right? So because it is in milliliters, I have to make it into liters. According to molarity the formula, volume of the solution should be in liters. Okay. Similarly, one more question. If I'm giving you, if I'm given with 120 grams of urea. Urea is NH2. You will be learning about this, more about this in grade 12 when you learn about organic substances. Urea is dissolved in 1000 grams water. Okay, find molarity if density is 1.12 grams per ml. Okay, now over here, can we find the molarity is given by number of moles of solute by volume of solution in liters, right? Now, I have the mass of solution, which is equal to 1000 gram. Sorry, I have the mass of solvent. Can I find the mass of solution? Do I have the mass of the solute? 120 plus solvent is how much? 1000. That gives you how much? That gives you 1120 gram, right? This is the mass of the solution. But I don't need the mass, I need the volume. So volume is given by mass over density, which is given by 1120 over 1.12, right? Which is equal to, when you solve it, you will get it equal to 1000 ml. And if I convert it into liters, it is equal to 1 liter. Okay, because this density is given by milliliters, so that's why I got in milliliters, and then I divide by 1000 to get 1 liter. Right. Now, molarity, moles of the solute is 120 by, how do you find moles? Moles equal to mass over molar mass. Nitrogen is 14, hydrogen is 1, oxygen is 16, carbon is 12, right? So it comes to 40 NH2CO NH2. There are 2 nitrogen atoms, 14 times 2 plus 4 hydrogen atoms plus 12 plus 16. It comes to 60. The molar mass comes to 60. This is the molar mass, okay? So we got the volume of the solution to be 1 liters, okay? Just remember that. So this is equal to 60 over 1 liter, which is equal to how much? 2 capital M. So students, this is how you find out the molarity when you are given the mass of the solution or mass of the solvent along with the density. Okay. So moving on further, just a few terms that you must remember. When I say bimolar, it is equal to, we represent it by 2m. Bimolar means 2m. If I say semimolar, it is half m, or we represent by 1 by 2m. If we say decimolar, these are just the terms they use in the question. When we do more of a past paper questions of the JEE and NEET, these terms will come into play. So that time you have to remember. Okay. So decimolar means it is 1 by 10, that is equal to m by 10. It is represented by m by 10. Centimolar means just like centimeter. Centimolar is 1 by 100, which is represented by m by 100. So these are the representations. So these are just few terms that you must remember, because they sometimes, instead of asking 10 grams of a semimolar solution of so and so, so like that, if semimolar you understand, it is equal to m by 2. Okay, so you can directly use it in the sums. Okay, so moving on further, students, molarity of ions. Okay, molarity of ions. What is an ion? You will be learning more about ions. Okay, but for now, molarity means something, ions means something that has charged particles like H plus, Na plus, or Cl minus. All these having charges are called ions. Okay, so molarity of ions. Okay, now if I students, our next topic about molarity is molarity of ions. Okay, so ions are nothing but charged particles. Any substance, any particle that has charge, Na plus, H plus, Cl minus, all these that charged particles are called as ions. Okay, so let's do this, do a question and understand the molarity of ions. Okay, so molarity of ions. Now suppose I'm given a solution of 500 or 500 ml of solution, okay, containing 53 grams of sodium carbonate. Okay, so I have to find the molarity of the solution, molarity of Na plus ion, and molarity of carbonate ions. Okay, so don't worry about the ions and all, because you will be learning equation, how to dissociate, etc. Okay, so for now, just remember the steps. That's it. Now, over here, sodium is 23, oxygen is 16, hydrogen is, I don't need hydrogen, right? Carbon is 12. Okay, now the first part of the question is I need to find the molarity. Molarity, you know by now, you will be knowing the formula. Molarity, number of moles of solute over volume of the solution in liters. So I'll do it directly. Molarity is moles of solute is 53 over sodium carbonate is 23 times 2 plus 16 12 plus 16 times 3, that comes to 106 over 500 milliliters, but I need to make it into liters, so divided by 1000. So this comes to 1 molar. So this is the molarity of the solution of what? Sodium carbonate, okay, in water, or they have not mentioned what solution it is. Sodium carbonate solution. Okay, so this is the first part of our question. Okay, now coming to the second part of the question, I need to find the molarity of. So second part of the question is I need to find the molarity of Na plus ion. Third part is carbonate ion. Okay. Now let's first dissociate the solution. Okay. Sodium carbonate, Na plus carbonate ions. Okay. How many sodium atoms are there? 2. Okay. Now over here, suppose I'm taking the balancing number as 1, okay, over here, because no number is there. So what is the meaning of this? 1 mole of sodium carbonate dissociates to give 2 moles of sodium ion, because I've taken the balancing number. I'm just dealing with the balancing number now, okay? And if no number is there, this next to carbon, that is 1, okay? 1 mole of carbonate ion, okay? Now, if we refer to the definition of molarity, number of moles in 1 liter of the solution. So that means this particular sodium carbonate, 1 mole of sodium carbonate is there in 1 liter of solution. What about sodium ion? 2 moles are there in 1 liter of the solution. And 1 mole of carbonate is there in 1 liter of the solution. So that means what is the molarity of sodium ion? Number of moles in 1 liter of the solution. Isn't it 2 molar? Over here for carbonate, 1 mole is there in 1 liter. So isn't it 1 molar? But there is a condition for this, that it is completely dissociated. There should be complete 100% dissociation. So as you move on in different lessons in grade 11 and 12, you will be learning about it. And also they would be giving you information in the question that it is completely dissociated. Okay. So this is how you find out the molarity of. So more about it, we will be doing it when we discuss more of the past paper questions. For now, please remember the formulas and the method to do it, especially when densities, etc. are given. Okay, and also the different concentration terms. Now the next one, what we will deal with is molarity of dilution. Now you will be knowing the meaning of dilution. Dilution means adding more of the solvent, okay, to dilute it, to increase the volume. Right. Now suppose I have, I'm taking a solution, okay, and suppose M1 is the molarity of that solution and volume is V1. Okay, suppose it's a solution of NaOH in water. Okay, M1 be the initial molarity of the solution and V1 be the initial volume. Okay, now suppose I'm adding more solvent or I'm adding more water. Okay, and I'm just assuming N is the moles. There are N number of solute, N moles of solute in that particular solution. Okay, just keeping in mind. Now M1 is the molarity and V1 is the volume, and I'm adding water to this. Okay. When I add water, what happens to the volume? Volume will increase, right? Volume will increase. Suppose V2 is the final volume after adding water. And because the volume has changed, molarity also changes, M2. Okay, and volume V2 is always greater than V1 because you have added water and increased the volume, right? Now, asking you a question, what happens to the number of moles? Number of moles. Does it increase or decrease? No, it doesn't change because you haven't done anything with the solute molecules, right? You have just added some water. So, number of molecules or number of moles of the solute does not change, right? Now, if the molarity of dilution is asked, you will use this formula. M1V1 initial volume, M1V1 equal to M2V2. This is the formula you use for molarity of dilution. Now, how did this come? Okay, you already know molarity is equal to what? Number of moles over volume in solution. So number of moles is MV, right? Now, in the first case, N is equal to M1V1. After dilution, what is the number of moles? M2V2. I just told you number of moles of the solute does not change when you add water because number of you have not done anything with the number of solute particles. So number of moles does not change. You have just increased the volume. So that means let's take this as N initial and N final. So N initial is equal to N final. So that means M1V1 is equal to M2V2. Okay, so number of moles of the solute does not change when you, based on this, we will do a question now. Okay, so I'm just writing this formula over here. M1V1 is equal to M2V2. 100 ml of HNO3 So based on molarity of dilution, let's do a formula. I have written down the formula over here. Okay. Now, hundred ml of 0.2 molar HNO3 is diluted with these types of a lot I have seen in competitive exams. Okay, diluted with 100 ml of water. Find the molarity. So what's the formula? We already have the formula in our hand. Okay, M1V1 is equal to M2V2. So over here, M1 is 0.2, volume is 100, equal to, what is the molarity of the final molarity? We need to find out, okay, times. What is the volume now, the final volume? Initial volume is 100, you added 100 ml of water. So what is the final volume? Is 200, right? So M2 is equal to 0.2 times 100 is divided by 200. Okay, so what does it come? 0.1 molarity. So if you know the initial molarity and the volume, you can find out the final volume or molarity based on the information, or vice versa. Okay, so this is the molarity of dilution. We will be solving this when we do the past paper questions. Okay, now the next one. Okay, students, our next topic is molarity of mixtures. Okay, suppose you mix two substances. Okay, now suppose I'm taking a substance or a solution, and molarity is M1 and volume is V1. I'm adding another substance, maybe the same solute, okay, with molarity M2, volume is V2, okay. And in the first case, maybe the number of moles of the solute is N1, because in the second case, I'm adding another, the same solute, but in different volumes, etc. The number of moles of solute be N2, okay. When I mix both of them, okay, I get a mixture with molarity M. When I mix both of them, I get molarity M, okay, and volume I can just add up, okay, V1 plus V2. And suppose the number of moles is N, okay. How to find the molarity of the mixture? So, N1 plus N2 will be the total number of moles of the mixture, right? So, N1 is nothing but MV, in this case M1V1, right? Plus M2V2. In the third case, what it is? M times V1 plus V2. So, this is our molarity of the mixture. Okay, this capital M is the molarity of the mixture. So, molarity of the mixture is given by M1V1 plus M2V2 over V1 plus V2. This is our formula which you need to memorize. You don't have to memorize how we derive this, but this equation, this formula is very important, because sometimes they ask you to, a lot of questions are asked on this part of the lesson or this formula, okay? So we will solve a question based on this, okay? And this is one of the JEE questions. I'll write down the formula at the side, okay? So molarity of mixture, molarity of dilution, all these are very important, okay? So I'll just write this formula. Molarity of the mixture M is equal to M1V1 plus M2V2 over V1 plus V2, okay? Now, based on this, let's do a question, okay? If 0.2 molar 100 ml HCl solution is mixed with 0.1 molar 300 ml HCl solution. So clearly they are mixing it. Okay, it's a mixture. Solute is the same. Okay. Find molarity of solution. Here they have not diluted it. See, they are mixing two solutions. The solute is the same though, but they are mixing two of them. So it's the molarity of the solution. So molarity of the mixture. Okay. They are not diluting it. They are mixing two solutions together, although the solute is the same. Okay. So over here, our formula, we already have the formula in our hand. We can use it directly. Capital M equal to molarity of the first one times 100 plus molarity of the second one times 100 divided by 100. Here the volume is 300, right? 300. Okay. Although you can see it is given in, when you solve this, if you solve this, you get the answer. So this is the molarity of mixtures. So mixing, you're mixing two solutions together. Okay, although in this case the solute is the same. Okay, so students, that's it for today. In the next video, we will be learning about normality and molality. These two concentration terms are remaining. Okay, and after that, we will start with solving our past paper questions. Okay, students, that's it for today. Thank you. Have a nice day.